Hi, I'm Alex Harris. I'm the founder of adadot.com. What we do is that we are a developer tool. We empower high-performing developer teams to reach their full potential with analytics, insights, and recommendations. I'm going to take you through today a bit of a presentation as to how you can use data to help developers and also become a better developer yourself. And I'm going to start with an example from a completely different field. So developers actually have a lot in common with athletes. Now, if you are like me and you grew up in the 90s and you've seen enough movies from the US, you'll be thinking that actually, the jocks and the nerds are fundamentally different. They sit in different tables and they don't really talk to each other. But in reality, they have much more in common than you think. And we're going to start with the athletes, in fact. Now, if we talk about athletic performance, most people think that athletic performance, starts poor when somebody's a beginner and they just start a sport. They then over time become intermediate, and after that they become advanced in what they do. So essentially it's a curve, but it follows a pretty kind of straightforward curve at that. However, that's a very simplistic view. And in reality, performance looks a little bit more like this. There's actually a huge amount of ups and downs, which tends to happen. And this isn't just for anybody kind of average doing sports, but even professionals like Serena Williams, top athlete in her field, are actually experiencing something very, very similar to that. So you can see here, there's been a lot of ups and downs. You can see where, she hit her peak. But you can see that after that, there's been some other wins as well, and some kind of big drops too. Now, the similar thing can actually happen if you look at performance for developers, and specifically if you look at the way they are committing code, but also how much of that code actually makes it into production error-free. And this is really interesting because if you ask most developers, they will assume they have a very kind of steady flow, but in reality, they have massive ups and downs. So you can see, for example, is it even the same person practically when we're looking at, I think what's September here versus the bottom down there, the drops. It's practically, you might be talking about 10 times, a 10x developer when you're hitting those tops. So why does this matter? Well, if you've seen the movie Moneyball, data is really king in understanding performance, but also driving said performance. And this is something that has revolutionized sports. So why not the development field, right? Let's go back to how data is being used in sports. So just as a quick example, over 50% of coaches will use performance analysis tools to provide video clips for other coaches and their support staff. About 68% of them, they collate quantitative game data. And just under half would use some form of live coding analysis during games. About 40%, roughly, would also receive a written match report, including game statistics. These are some quite large numbers. So if we use data, as I said, to revolutionize the athletic field, why not the development field? So why is this a problem and an opportunity as well? Now, it's an important problem to solve because there's about 60 billion of engineering productivity wasted in the US alone yearly. And whilst everybody else, pretty much every other kind of profit-driving department, marketing, sales, have data that live in tools like Google Analytics and Salesforce, engineering teams are flying blind. Now, in the same way that you wouldn't expect to go into a sales meeting and not know why you're hitting or not hitting your numbers, so do engineering teams when they're running a retro. What did we do well? What did we not do well? What makes us faster? What made us slower? A lot of that data at the moment is based on perception and impressions, whilst we need them to be based on fact. So why hasn't this problem been solved in the past? There's 3 reasons why this is very, very difficult to do. The first thing has to do with the breadth of factors that go into what an engineer does. So most people outside of the field would think that engineering is all about coding, but actually it's way, way, way more multifaceted. So a huge amount of importance goes into preparing, planning, scoping properly, understanding the requirements. And that's a lot of the work that is actually invisible most of the time. And especially when it comes to data capture, it's extremely difficult to try and understand how did we collaborate, how did we scope, how well did that process work for us? Secondarily, you have the complexity of the engineering frameworks. And the number 21 is, for example, how many engineering frameworks like Agile, Scrum, Kanban, etc. are out there. And 21 is the kind of broad number, like there's about 21 broad frameworks. But actually, in reality, every single team that has engineers will have a different flavor. Nobody implements those frameworks in their purest forms. Everybody would be working on something slightly different. The third thing is adoption. So it's really important if you're making anything for developers that developers need to love what you're making. And it doesn't just, it can't just be like a monitoring tool or something like that. It's super important that it's embraced and it helps the developers, the people in the trenches, the individual contributors, not just management. So how do we go about solving for these challenges? First and foremost, for the challenge of breadth, we take signals by integrating into a broad set of tools. So we look at code versioning, GitLab, GitHub. We look at task management like Jira. We also look at how people are managing their calendars. Google Workspace, for example, Outlook is the other tool. And we'll also look at how people collaborate over Slack. Now, why do we get such a broad view? Primarily because a lot of the things that cause bad code or a lot of the things that cause trouble for engineers don't actually have to do necessarily with coding. It might be, as I mentioned earlier, scoping. It might be the fact that they don't have enough focus time to focus on writing clean code. And these things are very, very important. Now, what do we do with this? First and foremost, we create insights. These can be anything from understanding where the blockages are in between reviewing code and committing code, and potentially understanding as well how the scoping worked that I mentioned a couple of times. And once we have that data, we do a couple of different kind of processes to it. First and foremost, we run 7 different models per engineer, per developer. And the purpose of running these models is to understand what drives positive performance, what drives positive momentum. So think about this almost like as a coach looking at the stats of the back of a game and understanding, what did we do right? So after understanding this, we take the 3 best performing models, we average them out, and this process happens daily. What that means is that for each developer, you have a personalized idea and also a personalized recommendation off the back of it as to what drives positive performance and how to improve said performance. Then finally, once we have the recommendations, we allow individuals and teams to create their own missions and to actually basically hit those goals that they've set for themselves and for the teams. Off the back of that, the teams and engineers can win rewards, which just makes the whole process a little bit more fun. So what does that mean for those developers? So the individual contributors actually benefit from being, for example, able to justify their promotion path or quantify some of the data they might need in order to have those conversations. This is not to say that this can be used as a monitoring tool. It's actually the exact opposite. We give power to the developer themselves to go into those meetings with that data, but their boss can never look downstream and actually basically say, Alex hasn't been doing any work. That's not how it works. But it does give the power to the developer to have these conversations and drive them. Other things like, if I'm a junior developer, am I building the right habits, or am I committing massive amounts of code? How quickly am I, for example, ramping up after I've been newly hired? And then how well am I managing my time? Am I, setting a focus time and keeping that focus time? Or am I struggling with that focus time and I'm getting distracted? And then finally, as far as managers go, are we investing the right amount of effort on the right things? Is a very kind of common thread of questioning. And then secondarily, what is impacting our velocity? Thirdly, what is the cost and resource allocation on the roadmap and technical debt? These are some of the questions that you might be asking. All right, so after all this information, we're off to seeing a demo. Hello, I'm Alex Harris, and this is an overview of the adadot platform. So we're going to start with this dashboard view. What you might notice here is that we have three pillars of data. We have work, we have collaboration, and we have well-being. Now, these numbers might not look familiar to anybody seeing this for the first time, but there's a good reason why we have them. First and foremost, you'll see, I'm going to show you in a bit, there's a lot of detail that hides between all of these different kind of data sets. And oftentimes what you want to be able to see is how directionally, how better we are one day after the other, but also the interplay in between those three factors. Because, for example, if you're working 24/7, obviously your well-being is not going to be as good and you're not going to have enough time to collaborate. So let's take work as an example and take you through some of the detail that exists behind that number. So the data here comes from GitLab and GitHub, as well as Jira, and in the near future, Notion. So as far as the sprints breakdown here is, you can see information around, for example, have we rescoped in the middle of the sprint? How are we spending our time and effort? Are we investing in building new features? Are we, having bugs? How are we actually investing into our engineering? As far as tickets assigned as well, you can see if they're equally distributed within the team or people have basically an uneven burden of tickets. Tickets are stuck. You can all see all of these things here. There's a lot of data around commits. You have data around deployments, which you can actually configure so that there's a level of customization that the platform can afford you, as well as pipelines as well, just making sure that you can see things like execution time, overall duration. And these charts are created automatically to fit exactly your process. Now, you can see where bottlenecks exist, in progress, under review, approval to merge, and you can also look at the health of your essentially review process. The important thing to note is that this version is for the individual. There's also one for the team as well, so you can actually click here and look at that data at the team level. The individual cannot be monitored by the manager and micromanaged. And what that means from an information architecture point of view is that the individual has access to their own data. The manager has access to the aggregate team data. Now, the other thing that we do here is, because obviously you can see there's a lot of numbers, there's a lot of little detail that sits under, collaboration, for example, things like, are we communicating publicly? Are we sharing our knowledge into public channels? In well-being, you can look at things, for example, like focus time. Are we setting that focus time in the calendar? Are we keeping it? Is our attention, really fragmented? Do we have a lot of content switching? So there's a lot of data that sits here. But going back to the kind of original insights view, how do we know what's making the most impact? And this is where the recommendations come into play. So here you can see basically the system will create recommendations per developer and per team, what will help them get faster, get better, give them a bit of a justification here as to why this is important, but also help them set their missions, which is, a type of goal you can set on the platform. There's 3 different levels of difficulty. And once you do that, they're super, super easy to track. You also have another broader collection of those goals, so those missions. So for example, if as a team you always want to make sure that you're merging, with approval, you can kind of pop that here, and you'll be able to set it. Same thing for developers at the individual level. They can set their own goals and they can basically drive their own kind of career and their own development path in a way. When these missions are completed, you can win those badges, and you can play that little game in that way. Now, finally, there's a really interesting new feature that we are releasing. It's called lead time, and that helps teams to understand what are the best ways to become faster, to essentially decrease their lead time. And this might not have to do with, for example, purely coding aspects. It might have to do with things like, for example, are we spending too much time in meetings? Is our review time or our review pickup time helping us, or is that holding us back? And if you click generate model, this creates a completely personalized model for each team. So this is unique in the market right now. And it's basically run by a causal AI model, which was first published in 2022. So a very, very recent kind of scientific evolution in this field. And with this, I'm going to stop. If you have any questions, feel free to message us.